Good morning, everyone. I hope everyone's having a great day here so far. We're going to get right into it. I see we got a few people have joined us already, but number of registrants today, so we're going to get kicked off right away. Yeah, just to get started, today we are going to talk about Looq data in AutoCAD Civil 3D specifically. Again, my name's Kevin Grover. I lead the customer success team here at Looq, and we are excited to kick this one off. And it's going to involve a bit of a live demo with a third-party products from AutoCAD. So hopefully all goes well. But we're going to dive right into it here for the webinar in January. So first off, for those of you that don't know anything about Looq, we are a reality capture platform that is a combination of a handheld photogrammetric device all the way through cloud processing. So we offer the QCam, which is the handheld system itself. It's a multi-camera system. It's got 4 integrated cameras, onboard GPS that we can get survey-grade GNSS data out of it, and onboard AI compute for doing some pre-processing before we submit to the cloud. Our cloud processing solution, QAI, is kind of the meat and potatoes behind it. So it's actually what does the photogrammetric processing to allow you to create high precision georeferenced 3D models, as well as all of the 2D and 3D products that we export out of the application. The web application itself is called QApp, and that is our easy to use kind of web service that allows you to collaborate, share, process, and upload and work with the data. So we offer a bunch of tools across the board, but those are basically the 3 tools that we've got as part of it. Quick overview again, how it actually works. So again, being a handheld system, we do have the ability to PPK, so post-process kinematic GNSS corrections. So this can involve you setting up a local base on a survey point. We can run CORS networks data. If you've got a PPK service that you use, you can get RINEX data from it. And then it allows you to actually use that for correcting the trajectory data within our processing solution. So you can walk around the project site, capture roadways, parking lots, sidewalks, overhead power, basically any data in 3D from an outdoor environment. And that's how we can basically use that to generate data in our 3D platform. We got, 30-minute capture that you can do on it. We've got a bunch of different processing options, but it allows you to get a high precision data set directly from the field. Our office processing, the data is uploaded from the QCam. We can do it via the web app, and this will basically turn it into an automated processing solution to create a point cloud, ortho, pano images. We've got tool sets in it for aligning to control. We've got some feature extraction tools to extract data as points, lines, and arcs, and then bring that into your CAD environment. So a lot of different exciting things we do within our product. But we've got past webinars on all of these, which we'll showcase at the end as well. We've got a webinar page that goes back through things about best practices and how to use different capture scenarios. But today we're specifically going to talk about the Looq data, and specifically in AutoCAD Civil 3D. So this is where I am going to stop sharing my here, and I'm going to jump over sharing some actual products. Give me 2 seconds. Ultra wide screen share. Come on. It's sharing too big of a window for me. We're going to do that. I'm going to share and hop over to ultra wide screen share. Awesome, but I am going to bring up this panel here first. So hopefully everyone can see. Oh, wow, my windows are really messed up here today. There we go. Hopefully that's going to work better. In a moment, it's going to work better. Okay, perfect. I think we're cooking with gas here. Sorry about that, everyone. What we're going to do is now in the web portal, so I've got a sample data set that I use for a bunch of this here, is if you haven't seen the process data, what we offer is a 2D and a 3D view of the data. This is the point cloud data we're looking in 3D, so it allows you to freely navigate to look around. This is just a small section of roadway that we use as kind of one of the test scenario areas that we do for a lot of our testing. So what we want to do is kind of walk through how to get data out of here into Civil 3D. So the biggest thing around it is you have to understand your data. I think that's one of the biggest challenge with it, and this is kind of when we look at the survey functionality we've got within our data set to start understanding a few things about our project. So what we do is the captures are all part of a site. So at the site level is where we can actually navigate in, and we do support different coordinate systems within our data. So within this site, when you're creating the site initially, is where you can actually set up things for your projection. We do support a wide variety of map projections in and around kind of globally. We've got a lot for US and Canada specifically. I am based in Canada, so we've got ones for specific datums for like the NAT83 CSRS, which is the Canadian version of the NAT83 datum. And this one is set up in UTM. So we can coordinate things for datums, vertical datums as well, because we can run different geoid models for our processing. So the goal of this is to make sure you do understand what coordinate system your data is in. That is the one challenge we've always had with the Autodesk products in specific. Other than the map products, etc., it struggles with some of the coordinate system functionality. So you have to understand which ones actually work for your project. But we do support the different EPSG codes. So this is the EPSG code for the data that I have specifically. So one of the big things, understand your data and what coordinate system it's in. So having said that is where the other side of it is when we do run through the data and the PPK processing, it is processed based on that coordinate system data and the base station that was used for doing the processing. The one feature you want to look at though is we do also offer the ability to fit data to survey control. So this is where in this case, I've actually imported survey control, we've aligned it to it, and we've got residual error data. So we know right off the bat that my data is actually aligned to survey control of where I want it to be. So if you don't care as much about accuracy, then that's where you can skip the ground control step if you don't really care about the absolute location of things. Maybe just trying to measure some heights and measure some distances. Our data is going to be very good for that just right out of the box. But if we want to be locked down to actually design from and work from and understand where it is in the world, is where you also want to make sure that it is aligned to survey control. So in this case, I've got this aligned. I've got very tight residuals. These are millimeters. So we're down to really tight data for over this small section of information. So I've got some confidence in my data now that my point cloud and my ortho image is all in the right coordinate space. The Files tab is where you can now go into your data product and where you can actually download things for the point cloud. We can download the ortho image. We've got a PPK report that you can download here as well. So a lot of different things, data formats. So these are the files that we're actually going to be using within the civil environment. So I've already got these pre-downloaded. You don't need to see me, watch me to download files remotely from my home. So I'm going to just minimize this and we're going to dive into the first one. So within the different AutoCAD products that are available is where we want to bring data in a certain way. So first step is going to be in recap. So I've got a project created already, but if we're going to create a new project in recap, you'll be going to import a point cloud. I don't have to save my changes here. And I'm going to create a new project. So I'm just going to call this webinar. And out of this is now where we want to bring in the output files that we've exported. So I have these downloaded in my computer already. So I do have the output file from the point cloud, which is an LAZ file. It's a compressed LAS file. And then I've got my output file of my imagery, which is a GeoTIFF. We've got a few different resolutions of it, but I'm going to be using the high-res resolution for this one. So those are the two formats we're going to kick off right off the bat. And that's where I'm going to bring my point cloud into here. So if I actually just drag and drop my LAZ file into here, this is now where there's some options that you want to be careful of when you're bringing data in to be used in Civil 3D. So there's some intensity clipping, which doesn't affect us since we don't actually have intensity data. We only have color. On the advanced tab is what you want to look at. So in our case, we want to set the coordinates as information. So this will be actually respected as part of the import, and it'll basically align in the right location within the products we're going to bring it into. So in the case of this, I'm going to bring up my coordinate system. And now you'll see that it's just going to have a big long list of all the coordinate systems that are available. But I know right off the bat that I'm running in a CSRS coordinate system for Canada. So you have to basically find the coordinate system from the list. It doesn't allow you to search by EPSG code from I don't remember. So I'm going to choose my NAT83 CSRS. I know I'm in UTM zone 12. I'm going to choose that one. I want to set that as my target as well. The reason why I want to set that as my target is that so it won't actually do any coordinate system conversions of my data. I know my data, I know what it's in, I want to lock it down in that format. So when you have that set is now when you would import that and bring that into recap directly. Maybe I've got my window actually resized a little funny here. Let me just, there we go. Now I've got the import file. So I will import, and that will actually start indexing and bring that into my data set. Now what it allows you to do is have this data set directly within here, and now I can actually start working with the point cloud within the different products. Just gonna actually cancel this one here and suspend that, and I'm gonna go into my pre-imported data set that I've already done within Recap here as well. So once it's imported, I now have the point cloud data within my Recap environment. And this is where they've got all sorts of tools for navigating and looking around and basically seeing this in a desktop environment. What I didn't show in the web viewer is the one other thing that we do also offer is classification support. So classification means that we've actually used a lot of our AI intelligence to start organizing data into feature classes of what they actually are. So this process is never perfect. We're constantly improving this through our imagery and the segmentation of the different AI that we've got, but we do a pretty good job of actually isolating a few things. So you'll notice out of it, we've got things like street lights that are classified in orange. As they go up, of course, are now in blue, but we've got some different intelligence within the data. Lamps, street lamps are basically classified a different way. But for my purpose of what I really care about in Civil 3D, might be maybe just a ground surface. So that's where we've got some classes where we've got the brown is the ground class, the gray is kind of roadways, sidewalks, roadways, and then purple is kind of our sidewalk data. So you can actually see that in Civil 3D here. Now, if you expand the side panel with classifications on, is where you can actually turn on classifications, and that actually allows you to see the different data products. So if I actually want to start turning some of these classes off, maybe I want to just isolate certain things. So again, you get the idea. You can see that we've already organized the data in a certain way, but now we're going to want to bring this data into our Civil 3D environment and maybe just work with this data from the classification data directly. So just wanted to show that to you here because Recap is a really, really good point cloud viewer. There's not a lot of functionality in here other than classifying some data. Again, you can manually delete and clean up some stuff, but when we bring this into Civil 3D is now there's some features within Civil that allow us to actually isolate the things we want and bring it into there. Maybe before I do that though, I am actually just also going to jump back to our web browsers. One other feature I didn't show, which is something else I do want to show within our data set too, is in the 3D view, we also have another tool for our Q survey. It's our virtual surveyor tool. So this is something where the point clouds are bigger files that are honestly challenging to work with in a Civil 3D environment. So we offer a tool even for virtual surveying, which allows you to basically create some survey point data and intelligence from our data that actually is quite easy to use within a Civil 3D environment. So typically to what you would do for a very conventional survey is you'd go out into the field and you'd actually start surveying certain locations that are of interest to you within the data set. So in this case, I've already pre-extracted this data, but this is just a matter of using our code library and extracting points and lines within our tool set. We do have a webinar about this one specifically and how to use the tool, so I'm not going to go over that one today. But what you can see here is we've got things like, I've got my back of curb, I've got my front of curb flow line. I've got a bunch of line work and point data kind of extracted already. So we've got a couple of ways to build a surface in Civil 3D. I just wanted to show you the tool out of this. It allows you to actually download this, which ends up creating just a CSV file of points. That's point, easting, northing, elevation, and then our descriptor codes. So we can also bring that into Civil 3D and actually create line work within the Civil 3D environment. So just wanted to show you that in here as well, is that we offer another tool set for doing some simple extraction. So now if I actually just jump right into Civil 3D now, is I've got a blank site set up. It is just a basic metric template, but there's a few things again that you want to walk through in the Civil 3D side. So on the settings tab, in here is where you want to right click and edit your drawing settings of your CAD file directly. I've already got this one set up for the coordinate system information on my end as well. But this is the other important part is you can now start choosing different coordinate systems, picking the right one. This is why we want to make sure that the coordinate system here matches the coordinate system of the data that you had within our portal. And the reason for that is just then the data translates in from 1 to 1. So we know as soon as we start importing the data, it's going to read it and read the coordinate system data and bring it into the right spot. If you are running metric, or for our US friends, the international or the US survey foot is also where you want to make sure that units are set properly. I'll share some links to our knowledge base afterwards as well. When you're in US survey feet, there's some things you have to do specifically around importing imagery and the point cloud in a different way because it struggles with US survey feet on a few fronts, but there's some things around making the AutoCAD variables to match, etc. But the concept's the same, is we want to make sure that these settings are set, but I'll share some documents out afterwards. In my case, it's a UTM metric system, so we're able to bring it in UTM directly. So I know that that's set up natively within my drawing already. So one of the first things that I like to bring in is, I can actually bring in the point cloud directly. So if I go to my Insert tab, there's the option to attach point cloud. So in this case, since I've already had my data set imported, I can actually just choose my webinar data set, and I'm going to import that in. I'm going to actually turn on zoom to point cloud. This is where you basically want to leave the settings as they are. I don't want to specify an insertion point. I don't want to change the rotation or scale because everything's set from the coordinate system data I'm bringing in. So when I bring, point cloud failed. Why did that fail? Oh, maybe because I brought in the wrong data set. Sorry, give me 2 seconds. Marquee small curve. I'm going to attach point cloud, and maybe I'm the wrong spot. Recap. Oh, sorry, marquee small curve. That's one that I want. Import. Now I've got the preview. I can see all my data that's set to 0, 0. It's going to import at the 0, 0 location just kind of natively and zoom to point cloud. So I press OK. Now you see that I've actually zoomed my data in, and it's brought me to the location of my data. There's a couple of ways we could check some of these things. One of the nice things is I like going to the geolocation tab. Because we have the coordinate system set, I can now actually turn things on, and I can turn on, say, I'm going to turn on maybe my Esri imagery mapping in the background. So what this is going to do, it's going to natively import the map data on the back end. You notice it doesn't seem to line up, but this is also one of the challenges with data that's out of date, is now I can actually zoom and I can see my point cloud. So Esri has different tiling as Google Earth does, as well as some of the tiles will update over others. So as I zoom out to a grander scale, I'll see my data. But now I can actually check to make sure that my thing's lining up. So it's not going to be perfect, but at least it gives you a bit of an idea. Did I bring my data in the right spot? Do I have my unit set the right way? So now it's just kind of a quick little check to see if everything's in the right location. So I'm going to turn that off again since I'm quite confident now I've got my point cloud loaded there. The next thing I want to bring in is my ortho. So in this case, I want to do map.i insert. So if anybody is not familiar with map commands, map.i insert is the command to basically insert a georeferenced image where I've got the world information or some sort of coordinate information defined for my image. So when I choose map.i insert, I will just pick the image that I will import and press open. And this will now allow me to bring in that image in the right location. So in this case, it has now brought in the image. Oh, sorry, it brings up an image correlation. With the units properly set in your drawing and with the units set with the coordinate system information from what we exported, it's now everything set up to be proper. I can just accept these and click OK. And now I've actually got my ortho imported in the right spot. I just got to change my draw order. And I'm going to bring this to the front. And now, actually, I think it's because the elevation's out of the way. So what I'm going to do is actually, I'm going to hide my point cloud. And now I can actually see my ortho image. So we offer 2 data sets. The ortho is a really nice data set to bring in to a CAD environment because it's a nice lightweight data product that I could actually start working with. So now we've got the ortho and the point cloud within here. I'm going to end my isolation. The one thing you'll notice is if I choose my point cloud, it comes up at the top here. Now I can actually change it to see by the settings that we've got. So I can choose by scan color, which it defaults, or I can choose by classification, which I showed in the browser. So the problem what we've got now is that the classification is visible within a Civil 3D environment, but it doesn't allow you to do anything with it at the moment. I can choose create surface from point cloud, which has its challenges here at the moment. If I go and I'm going to just create next, it's got some ways to create the point cloud. So it knows that I've got my point cloud selected. I'm going to use it. And then it's got some options for actually doing basically a classification from the data already. This is an extra compute thing that basically is already done, or that will be done on the AutoCAD side. There's a planar average and a Kriging interpolation option, or there's the option to do no filter. The challenge with no filter is that it's going to put poles and fence lines and buildings and everything into my surface, which I don't want. I really only want to work with ground data. So in this case, I don't want to redo it because we've already classified this data. So what you want to do now is it's a buried tool that you have to now know some map 3D commands. So this is where we're going to bring up the map panel. So there's the option for map W space, or you can basically change your, up here, you could change to the planning and analysis one, which will bring up the map space. But in my case, I just want to actually bring up the map W space here directly. And it's going to bring up a little side panel. I'm going to turn that on. And now I'm going to bring up a side panel on the side here. So kind of a cryptic way that they've got this in here for AutoCAD, but whatever, you do it once and you'll be able to do it again. Data is now where I'm going to add point cloud data, and I'm going to do from drawing object. So in my case, it detects the point cloud. I've got this data here. I can choose OK, and now it's attached it to the side. Now when I actually select that data set, I can filter my point cloud. And this is kind of the roundabout way getting into the classification data that we talked about initially. So the one thing that we do want to be aware of is we do follow the ASPRS classifications. We do have these kind of within our support documentation as well. There's a bunch of standard ones from 0 to 9 that are what they are. So we follow the ground classification. There's vegetation, buildings, etc. There's a whole bunch of reserved classifications as well that we do actually use on our end. So class 11 is actually a reserved class, and it's one that is actually meant for road surface. So in our support documentation, we indicate which classes we want to identify. So in our case, we need ground reserved as being 11, and then also class 66, which I don't know. And actually, for some reason, I just noticed this is AutoCAD seems to have an issue of not actually having every class here. So we do have classifications up to 66, but for some reason, I can't actually get them. So I'm going to have to do this with only ground and reserved. So something I might have to talk to AutoCAD about. Anyways, if I take this and if I apply my filter, what this is going to do is now you've actually seen that it's turned off a lot of the data within my data set. So I've got my ground classes that are the brown, the road classes that are in gray. So now I actually have the classes filtered. So if I wanted to now create a data set from that point cloud, my point cloud is now filtered with the map tools. So if I now go back into the tool to create surface from point cloud, and I want to run this tool here now, I'm going to go through and just create this. I'm going to select points, and then I would choose no filter. What this is now, it's going to create a surface purely just from the filtered data I've got on my screen. So I'm going to create a surface. This is now being done in the background, and it'll basically create a surface for me from the point cloud. Do I recommend this as a way to create a true ground surface? No. The challenge with this, of course, it's creating it from a big series of mesa points. If you're doing like just basic topography for like a landfill or something that doesn't have break lines you care about, that's something where this will work quite well because it's going to create a surface from a bunch of unordered data. This is still where, from a survey perspective, is where you also would need to use tools like Breaklines and honestly simplifying the data a little bit, because this is going to be a pretty heavy surface that's going to be created. So we'll show you when that's done here. In the interim, while that's working, I'm going to jump over. I'm just going to detach the image for a second here, just so it's out of the way. And zoom extents. Oh, did I delete my point cloud? I must have deleted my point cloud. Undo, erase. All right, there we go. Instead of that, I'm just going to hide my image. So I've got my point cloud here. But what I can also do is bring my data in from the survey database. So for those of you who haven't used the survey database, I could actually go through. I'm going to create a new local survey database. And I'm going to call this as webinar 3. And now this is where I can bring in the points that I've extracted from my point or from my virtual surveyor tool. So I'm going to go to my survey points, and I'm going to, import events, and I'm going to import survey data. In this case, I'm going to use this, and I'm going to choose my point cloud file. I just got to be cautious of time here because I'm going to be running out of time. Look, marquee, sorry, look, webinar. And I've got my point cloud data in the CSV format. Sorry, I'm looking at a different screen and not sharing here. I've got my source file. So if I go into here and I search for my CSV file, I've got my topo CSV file that was done. I'm going to open that up. It doesn't find the format that I need, so that's where I now actually have to choose the format. In this case, I need point easting northing ZD, comma delimited. Oh, sorry. And it's not auto-detecting that. There we go. Point easting northing space, no, comma delimited. There we go. So I've got it as point easting northing elevation description, and I'm going to bring that into my data set. And actually I have to block out the first column, which isn't there too. So you would import this into your file, into your survey database, then you can actually bring this into my data. So in this case, I'm actually just going to open my pre-configured one, and I'm going to import my data into my drawing. So if I import this in, this is now where I've got my points and my break lines added into my drawing, so I can use those to basically help redefine my surface. Oh, and maybe that's the end of my demo here, is I've got a crash for Civil 3D. So I made it to the end of the product. Hopefully you kind of get the gist of where things are at. I've got a fatal error here, so hopefully this isn't held against Looq. This is hopefully an AutoCAD issue, but this is now where you would bring the data, and you can now have your data available to work with. So I've got my points, lines, and arcs imported. I've got my image imported. I have a point cloud imported into it. So now I could actually use these to start working within a Civil 3D environment. So on that note, I guess I am going to have to stop my sharing there, and I'm going to bounce back to my with I want to present. Yeah, I see Looq is texting me on the side here. Yeah, it happens. I guess that's the challenge with live demos here. I'm going to go back to my Looq in Civil 3D PowerPoint I'm going to share. And we'll just wrap up here with a couple of closing options here for the webinar. So we do have a couple things. Maybe Teresa, I'll hand this over to you while I get the sharing going here properly.
Yeah, so we do have another webinar coming up on February 3rd, focused on linear survey projects. So feel free to go ahead and register. I just put the link in the chat. The events teams link there is the one you can go ahead and register for that if you want to, so you don't have to think about it again until February 3rd. Also, we are live with the user conference, and we do have early bird registration through January 31st. So that's coming up in a couple of weeks. So if you're planning on coming to the conference, please do go check out the user conference site. Link is also in the chat. And see what kind of savings you can get through January 30th. So if you are planning on registering, you want to try to capture those savings. And we're here and happy to answer any and all questions about the user conference or the webinar series. So thanks for joining, and hopefully we'll see you in May.
Awesome. Thanks, everyone. And I guess, yeah, we'll open up the chat. I'm just going to stop sharing here. If anybody has questions, yeah, feel free to put them in the chat or the Q&A. I don't see anything just yet. I apologize for the crash in Civil 3D. It does happen when you're working with point clouds. So
I don't see any hands raised. I'm just double checking Q&A and chat right now. Don't see anything just yet. I'll try to unmute you if you'd like to ask your question live. Just raise your hand.
the going once thing, if nobody's got any questions, we'll give some time back in people's day. All right, silence is acceptance. Thank you, everyone. We appreciate it, and stay tuned for the next webinar that we'll have in 2 weeks for doing some linear corridor workflows, specifically for survey and roadway projects. Thanks, everyone. Take care.